This is SpaceTime, Series 28, Episode 120, for broadcast on the 6th of October 2025. Coming up on SpaceTime, a new study warns the universe will end in 20 billion years from now, a new three-dimensional map of our Milky Way galaxy, and how fungi set the stage for life on land on planet Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims the universe is now approaching the midpoint of its 33 billion year lifespan and will come to an end in around 20 billion years' time. A report in the Journal of Cosmology and Astroparticle Physics says calculations based on new data from dark energy observatories suggest that after expanding to its peak size in about 11 billion years from now, our universe will begin to contract, eventually snapping back like a rubber band to form a singularity at the end of time. The study's lead author, Henry Tighe from Cornell University, says he reached his conclusion after adding new data to a model involving Albert Einstein's famous cosmological constant, a factor introduced more than a century ago by Einstein and still used by cosmologists today to predict the future of the universe. Tighe says that for the last 20 years, scientists have believed the cosmological constant was positive and the universe would therefore expand forever. But he claims the new data seems to indicate that, in fact, the cosmological constant is actually negative and the universe will end up in a big crunch. Right now, the universe is 13.8 billion years old, and it's still expanding. Now, according to current models based on dark energy, its two simplest fates are that it'll either continue its present expansion forever, that's if the cosmological constant is positive, or alternatively, if the cosmological constant is actually negative, it'll reach a maximum size before contracting, eventually collapsing back to zero. Tighe says this big crunch defines the end of the universe, and he says that'll happen in around 20 billion years from now. The findings are based on observations by the Dark Energy Survey in Chile and the Dark Energy Spectroscopic instrument DESI in Arizona, which are both in good accord with each other's data. The whole idea of the Dark Energy Survey of these two groups is to see whether dark energy, which makes up roughly 68% of the mass energy budget of the universe, really comes from a pure cosmological constant. The authors found that the universe is not just dominated by a cosmological constant known as dark energy. Tighe and colleagues propose there's a hypothetical particle of very low mass that behaved like a cosmological constant early in the life of the universe, but doesn't anymore. And it's this simple model which fits the data so well and tips the underlying cosmological constant into negative territory. Tighe says scientists have said before that if the cosmological constant is negative, then the universe would eventually collapse. That's not new. However, here, the model tells you when the universe collapses and how it collapses. Hundreds of astronomers are busy measuring dark energy by observing millions of galaxies across the cosmos and determining the distance between these galaxies, gathering more and more accurate data to feed into the model. DESI will continue observations for another year, and observations are ongoing or will soon begin with several other dark energy observatories, including the Zwicky Transient Facility in San Diego, the European Euclid Space Telescope, NASA's recently launched Sphere-X mission, and the Vera C. Rubin Observatory. Tighe says knowing both the beginning and the end of the universe provides a greater understanding of the cosmos. As to where the universe goes once it contracts down into a big crunch, well, the answer's simple. The universe goes into the future. This is SpaceTime. Still to come, a new three-dimensional map of our Milky Way galaxy and how fungi set the stage for life on land on planet Earth. All that and more still to come on SpaceTime. The European Space Agency's Gaia Space Telescope has created the most accurate three-dimensional map yet of star-forming regions in our Milky Way galaxy. This new map will teach astronomers more about these obscure molecular gas and dust clouds and the hot young stars born within them and which ultimately shape them. It's notoriously difficult to map and study regions of space where stars form because they're usually hidden from view by thick clouds whose distances cannot be accurately directly measured. Now, Gaia itself doesn't see these clouds, but it can measure stellar positions and the so-called extinction of stars. This means it can see how much light from the star is being blocked by dust. From this, astronomers can create three-dimensional maps showing where the dust is and use those maps to figure out how much ionized gas is present, a telltale sign of star formation. The new three-dimensional map of star-forming regions in the Milky Way is based on Gaia observations of some 44 million ordinary stars and 87 spectral type O blue stars. The map extends out to a distance of some 4,000 light-years. Spectral type O blue stars are rare. They're young, massive, and extremely bright and hot, and they shine bright in ultraviolet light. These ultraviolet photons are so energetic they can quite literally strip electrons away from hydrogen atoms when hitting them. In this way, they ionize the hydrogen gas around hot stars, meaning it becomes a mixture of charged particles. Astronomers call these ionized hydrogen clouds hydrogen 2 regions. A characteristic signal that can be picked up from these regions is the hydrogen alpha or H-alpha spectral line at a wavelength of 656.3 nanometers. This is one way that astronomers can identify regions in space where stars are being born. Many telescopes have observed these regions, so astronomers have a good idea of what they look like. But no one really knew what they look like in 3 dimensions or from an outside perspective, and that's where Gaia comes in. Gaia has mapped the positions, velocities and motions across the sky of billions of celestial objects, including millions of stars. The result is the most accurate multidimensional map of the Milky Way galaxy ever created, and it's giving astronomers the data to infer what the galaxy would look like from the perspective of someone outside the Milky Way. Gaia's sky maps in all 3 spatial coordinates, plus 3 velocities, that is moving towards or away from the Earth and moving across the sky, have revealed the precise motions and positions of millions of nearby stars. With this, the telescopes already revolutionized science's view of the solar neighborhood, allowing astronomers to comprehensively map the stars and interstellar material near the Sun in a way that they were simply unable to do before. One of the study's authors, Lewis McCallum from the University of St Andrews, says Gaia is providing the first accurate view of what our section of the Milky Way galaxy really would look like from above. He says there's simply never been a model of the distribution of ionized gas in the local Milky Way that matches other telescopes' observations of the sky so well. That's why astronomers are so confident that Gaia's top-down view and fly-through of the galaxy are a good approximation of what these clouds would really look like in 3 dimensions. Lewis's new map includes 3-dimensional views of the Gum Nebula, the North American Nebula, the California Nebula, and the Orion-Eridanus superbubble. This data will allow astronomers to learn more about how giant spectral type O stars energize gas and how far out their influence can reach. Lewis and colleagues already noticed that some of the clouds in the star-forming regions seem to have broken open, and streams of gas and dust are likely venting into a giant cavity. The map also shows how radiation from massive stars ionizes the surrounding interstellar medium, and how dust and gas interact with this radiation. The 3D model provides a detailed look at the processes that shape our local galactic environment, and it helps astronomers better understand interactions between the warm and cold components of the local universe. In the future, this map, which requires huge computational power to develop, will expand even further, including an even larger area of our home galaxy. This report from ESA TV.
What does the Milky Way look like from the outside? No spacecraft can travel beyond our galaxy, so we can't take a selfie. But during its lifetime, Gaia made 3 trillion observations of 2 billion stars and other objects, giving us the best insight yet of what our home galaxy looks like. We can identify the Milky Way's central bar and its spiral arms based on Gaia data. We see the galaxy edge on and can identify its bulge and disk. Gaia showed that our galaxy's disk is warped and wobbles, possibly caused by a collision with another smaller galaxy. Moving further out, Gaia also studied other galaxies around the Milky Way, such as the large and the small Magellanic Clouds. and 40 other companions. Gaia revealed our galaxy's turbulent history by tracking the movements of streams of stars. Gaia gives a unique view of our Milky Way, scanning our galaxy from the inside out, building a more detailed map than ever before, fundamentally changing what we thought we knew about our home galaxy, where our sun is embedded among billions of stars.
This is SpaceTime. Still to come, how fungal set the stage for life on land on planet Earth, and later in the science report, a new study says people whose parents have mental illnesses are more likely to die prematurely. All that and more still to come on SpaceTime. A new study examining life's evolution on planet Earth has found that fungi set the stage for life on land somewhere between 900 million and 1.4 billion years ago. That's hundreds of millions of years earlier than previously thought. The findings, reported in the journal Nature, Ecology and Evolution, used a novel gene swap method to shed new light on the timelines and pathways for the evolution of fungi. The discovery by researchers from the Okinawa Institute of Science and Technology provides evidence for the evolution of fungi-run terrestrial ecosystems and therefore the emergence of life on land. It suggests these ecosystems recycle nutrients and possibly partnered with other organisms. Pinning down their timelines shows fungi were diversifying long before plants and consistent with early partnerships with algae that likely helped pave the way for terrestrial ecosystems. Complex multicellular life, that is, organisms made from many cooperating cells with specialized jobs, evolved independently on Earth on at least 5 major occasions: animals, land plants, fungi, red algae, and brown algae. Understanding when these groups emerged is fundamental to piecing together the history of life on Earth. See, complex multicellular life wasn't simply a matter of cells clumping together. It was the dawn of organisms, where cells took on specialized jobs and were organized into distinct tissues and organs. For most of these groups, the fossil record acts as a geological calendar, providing anchor points in deep time. For example, red algae shows up as early as 1.6 billion years ago in candidate seaweed-like fossils from India. Animals appeared around 600 million years ago based on Ediacaran fossils such as the quilted pancake-like Dickinsonia. The first land plants took root roughly 470 million years ago, based on the discovery of tiny fossil spores. And brown algae such as kelp diversified tens to hundreds of million years later still. And based on all this evidence, a chronological picture of life's complexity starts to emerge. But the notable exception to this fossil-based timeline has always been fungi. The fungal kingdom has long been an enigma for paleontologists. Their typically soft filamentous bodies means they rarely fossilize well. And unlike animals or plants, which appear to have a single origin of complex multicellularity, it seems fungi evolved this trait multiple times from diverse unicellular ancestors, making it difficult to pinpoint a single origin event in the fossil record. To overcome the gaps in the fungal fossil record, scientists are relying on the steady rate at which genetic mutations accumulate in an organism's DNA over generations. By comparing the number of genetic differences between two species, scientists can reach an estimate of how long ago they diverged from a common ancestor. The problem is this molecular clock is still uncalibrated. It can reveal relative time, but not absolute years. To set the clock, scientists need to calibrate it with anchor points from the fossil record, and given the scarcity of fungal fossils, this has always been a major challenge. The new study addressed this by incorporating rare gene swaps between different fungal lineages, a process known as horizontal gene transfer. While genes are normally passed down vertically from parent to child, horizontal gene transfer is like a gene jumping sideways from one species to another. And if a gene from lineage A is found to have jumped into lineage B, it establishes a clear rule. The ancestors of lineage A must be older than the descendants of lineage B. By identifying 17 such transfers, the authors established a series of older-than-younger than relationships that, alongside fossil records, have helped to tighten and constrain the fungal timeline. The analysis suggests a common ancestor for living fungal dating to between roughly 900 million and 1.4 billion years ago. That's well before land plants. That timing supports a long prelude of fungal-algae interactions, fundamentally reframing the story of life's colonisation of land. It suggests that for hundreds of millions of years before the first true plants took root, fungi were already present, likely interacting with algae in microbial communities. And this long preparatory phase may well have been essential for making Earth's continents habitable. By breaking down rock and recycling nutrients, these ancient fungi may well have been the first true ecosystems engineers, creating the first primitive soils and fundamentally altering the terrestrial environment. It means plants didn't colonise a barren wasteland, but rather a world that had already been prepared for them over eons by the ancient and persistent activity of the fungal kingdom. Meanwhile, a report in the Journal of Proceedings of the National Academy of Sciences has unearthed new evidence in the ancient rock record suggesting that some of the first animals on Earth were likely ancestors of the modern-day sea sponge. The study's authors identified chemical fossils that may have been left by ancient sponges in rocks that are almost 541 million years old. A chemical fossil is a remnant of a biomolecule that originated from a living organism that has since been buried, transformed and preserved in sediment, sometimes for hundreds of millions of years. The newly identified fossils are special types of steranes, which are a geologically stable form of sterols, such as cholesterol, that are found in the cell membranes of complex organisms. The steranes were found in rocks formed during the Ediacaran period, between roughly 541 and 635 million years ago. That's just before the Cambrian explosion, when planet Earth experienced a sudden global explosion of complex multicellular life forms. The authors traced these special steranes to a class of sea sponges known as demosponges. Today, demosponges come in a huge variety of sizes and colours, and they live throughout the oceans of the Earth as soft filter feeders. The new discovery offers strong evidence that the ancestors of demosponges were among the very first animals to have evolved, and they likely did so much earlier than the rest of Earth's major animal groups. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have found a significant link between drinking soda beverages and depression. The findings, reported in the Journal of the American Medical Association, also showed that this effect could be significantly mediated by how much of a specific bacterium called Egethelia existed in a person's intestinal tract. The authors looked inside the soft drink habits and microbiomes of almost 1,000 people, just over 400 of whom had been diagnosed with major depressive conditions. They believe that drinking pop may contribute to the condition through microbiome changes, especially those involving Egethelia in female patients. While this kind of study cannot prove a direct connection between soft drinks and depression, the authors are suggesting prevention strategies that reduce consumption of these drinks and target the microbiome in treatment. Scientists say people whose parents have mental illnesses are more likely to die prematurely up to middle age. The findings, reported in the Journal of the American Medical Association, examined medical records for more than 3.5 million Swedish people, around 1.2 million of whom had parents with mental illnesses. They say the link between parental mental illness and premature death held true for all mental disorders and was strongest for unnatural deaths, which include suicides, murder and accidents, and if both parents were diagnosed with mental disorders. The findings highlight the importance of providing support for families with parents with mental disorders in order to minimise premature deaths among their children. One of the oldest people in the world who died just last year at the ripe old age of 117 may have survived so long because her body was still working as if she was at a much younger biological age. Among signs of a healthy body, the journal Cell Reports Medicine found that her DNA had markings usually found in younger people, and that she had rare gene types linked to long life. They also found differences in her microbiome, including having more of a type that people typically lose with older age. The researchers say this shows that old age doesn't always have to be linked with disease. The glittering highlight of the Australian Skeptical calendar is the annual Skepticon conference, which this year was held in Melbourne. Of course, one of the highlights of the event is the highly coveted Bent Spoon Award, which is presented annually to the perpetrator of the most preposterous piece of paranormal or pseudoscientific piffle. The award is rumoured to have been fashioned out of a piece of gopher wood salvaged from Noah's Ark. Upon its sturdy base is affixed a spoon rumoured to have been used at the Last Supper. The spoon was allegedly bent by Uri Geller using old magic, energies unknown to science. Past winners of this elegant trophy for displaying a total lack of scientific understanding or an ability to pile the bull up high have included the Australian Broadcasting Corporation, the ABC, for demonstrating new lows in journalistic standards with their motto, "Never let the facts get in the way of a good story." The University of Wollongong for proving once and for all that you don't need to be smart or even right, or for that matter scientifically accurate, in order to get a doctorate. Then there was the Adelaide psychic Anne Dankbar for her discovery of the Colossus of Rhodes, which created something of a media frenzy till it was shown to be nothing more than modern builder's rubble. The ABC won it again for their television show Second Opinion, which promoted so much unscientific quackery that they really should have gotten a few more opinions. Southern Cross University was another award winner for offering a degree course in naturopathy. Even the once exalted CSIRO has been awarded, with its chief, Larry Marshall, getting a special mention for his support of water divining. The ABC won the award yet again for spending taxpayer money on psychic investigators. Then there was racing driver Peter Brock, whose highly touted energy polarizer generated more heat from the motoring media than what it did energy in his car. The special broadcasting service SPS won the award for their TV program Medicine or Myth. They were promoting alternative medical treatments as if they had some actual scientific credibility, as opposed to being nothing more than an occasional placebo effect. The Melbourne Metropolitan Board of Works won their award for hiring a US psychic archaeologist to help detect non-existent electromagnetic photo fields. Oh, and once again the taxpayer-funded ABC won the award, this time for their television show The New Inventors, which seriously considered the pseudoscientific benefits of an anti-bio-water conditioning system, which probably should have been filtered through the kidneys a few more times. In case you're wondering, that's more than $1 billion of Australian taxpayers' money spent by the ABC every year. And of course, there was Paleo Pete Evans for his promotion of the Biocharger, a miraculous device that, according to its manufacturers, has been proven to restore strength, stamina, coordination and mental clarity. Like the ABC, Evans was a multiple winner. He previously won the spoon back in 2015 for his paleo diet advocacy, which included promoting bone broth as a formula replacement for babies, as well as his campaigns against fluoridation and vaccination. Tim Mindham from Australian Skeptic says this year's exalted winner was banned naturopath Barbara O'Neill.
The Ben Spoon Award went to a lady named Barbara O'Neill. Barbara O'Neill is a self-entitled naturopath, even though she doesn't have any qualifications, who was running a retreat in New South Wales, up in the sort of forested areas in the north, and various people, including a number of skeptics, complained about her activities and what she was saying, and then the New South Wales Healthcare Complaints Commission took action, looked at what she was saying, realised what she was saying was extremely dangerous, totally unqualified and wrong, and they actually banned her for life for practising in Australia in any medical capacity at all. So what she's done now is she goes overseas and streams stuff. She's been big in Ireland, in the UK and in the US. She has a tendency to suggest people rub garlic and onions and things like that on them.
Vampires, isn't it?
To get rid of vampires, if only. It would be very handy. To cure all sorts of things, everything from cancer to medical conditions of some sort or another, mental conditions even. We always had the suspicion that because she's recommending so many vegetables, she's being paid for by Big Pharma. Boom, boom. But she is totally unqualified, even though she occasionally allows herself to be called doctor. She is not. She's been very active in the last year. A lot of people see as what she's suggesting as not being dangerous in its own right. Rubbing onions on your foot is not going to kill you. But the trouble is she is saying, don't do chemotherapy, don't do this therapy, don't do that therapy.
It's going to kill your social life.
But it also sort of means you're turning away from actually medical procedures that do work in favour of this quack cures that she promotes. And that's where the danger is. She's anti-vaccination. She's all the usual anti-things.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.